Okay, second video on interconnect physical structure. The last one we talk about there are five metal layers and vias in between, and their dimensions, pitches, thickness, width, aspect ratio. Next question is what are they made up of? So if you look at this one, let me do that. This is a metal line. And this one I know one is horizontal, one is east to west, one is north to south, but in this one I guess I put them in a similar way. That's okay. The concept is same. So these metals, metal 1, metal 2, metal 3, metal 4, metal 5, M1, M2, M3, M4, M5. They are in its core, the main line is made of aluminum and then 5% copper, so it's called aluminum alloy. The reason for copper, I took some notes and it's from that research paper on Intel 250 nanometer. I think if you search that, it's available for free download somewhere. Copper is used to improve electromigration. Electromigration is a phenomena. I think I might cover that under reliability, but it's a phenomena through when a lot of current flows. Ideally, we want only electrons to flow, not the atoms altogether. But if the speed is too high, they can really move the atoms of the material, and which damages the material. So can create all sort of problem when current keeps flowing through a metal over a longer duration. Your chip will be in customer hands working 24 hours, 365 days, for so many years, right? Think of those internet boxes that we have, routers. They're always on. So, over time, we need to be aware for interconnect. Okay, what kind of damage can happen because of the lot of current flow, especially the higher metals that you have seen. They're huge. They can they can have a lot of current flow through them, and that can create some issues. Even at a lower level, if a high frequency current flows through them, that um, so what we do is we mix a little bit of copper, which gives aluminum protection against that. Okay, so the second thing is then they also, and you don't need to remember that, but just to give you an idea that, okay, what kind of different mixture of metals they use. So if you use aluminum alloy, they might add around or on top uh, titanium nitrate. It does some additional improvements. For example, this one will give a protection. It's a nice barrier into another metal that you connect to. It will provide protections during the etching. I think I need to give one videos on a general process for manufacturing, and we remove a lot of stuff is deposited, lithography is done, then a lot of stuff is removed. So once you put this one and you are putting more layers on top of it, you want to make sure the bottom ones are not damaged. So for some of those, and reducing reflections, ensure good pattern. Yeah, so you put light on it, and you want to make sure that light is used to create patterns of different metals. And if reflections happen, they might not create a nice metal structure. So there's a use of that. On the bottom side of each metal, titanium is used, and it also for good barrier and also good adhesive. Remember that one. In this case, we use this black thing here, titanium, and titanium nitrate, silicide. Anyway, for those, some of the adhesion, nice barrier into another metal, and ensuring that copper, for example, if it's connected on top of a via here, it doesn't go into the silicon, the copper, and doesn't damage that. So, and each technology has some different thinking about it to make it better for manufacturability, and aluminum is much better um, for um, for conductor, as a conductor, and copper um, is also, and we will see how some of the materials change over time. And when I look at some of the people, I'll explain you why not aluminum and copper, or vice versa. But just to give an idea, different thoughts and different engineering things and physics and chemistry and all that play a crucial part in transistor buildup. What are vias made up of? So these guys here, what are these made up of? These made up of tungsten, and it's a good conductor. It's a high melting point. Now think of that. All the current that is flowing through metal, that's huge metal 4. Eventually, through a small hole, it has to go to metal 4. And then. So for these ones, sometimes very high current can pass. So tungsten provides a high melting point. And it's also good for electromigration. That gradually it ensure that not atoms start moving, especially on the surface. Um, and it's also a barrier to other metals, like when it acts nicely, goes into metal here, so the structure is not damaged. So it's basically, think of like as a building. You need to have a solid structure, you need to be able to fabricate nice structure, you need to put them on top of each other so that the electrical characteristic, the whole scheme of electron flow, current flow through different transistor and between different transistors is ensured. Okay, I think we covered we covered metal, and what we didn't cover, you probably be thinking, or I don't know if you thought about it, what is inside these empty areas if there is no metal use? So those empty areas are filled with different oxides, the dielectrics. I think I mentioned interlayer dielectric. That's a term used between different layers. There is an empty, and that is filled interlayer dielectric, or between this and this. And there are different material used. I think in the paper also mentioned, okay, this BPSG, a long name, is used for between poly and first metal, and between other metal, and a different one is used. I never remember those, but a nice thing to remember. Okay, I think I covered what I wanted to cover. If something I remember later on, I might do another video. Okay, but if nothing else, then the next video will be on the delays side of things, the resistance, the capacitance, and all that, how you can estimate delays. All right, that's it for now. Thank you so much. Bye.